I want to show you a couple of examples where we use the double angle identities to find some trig values. So the problems that we are working on right now typically give you one trig value. For instance, right here, you're given that the sine of theta is negative 4/5, and you're asked to find the sine of 2 theta. So when I look at this request, that tells me which one of my double angle formulas I'm going to need to use. So right away, I see that I'm going to use the sine of 2 theta formula. And that formula written out is simply this. The sine of 2 theta equals 2 times the sine of theta times the cosine of theta. And essentially what we need to do is we need to plug in the value for the sine of theta and the value for the cosine of theta into this equation, and we'll get the value that we're asked to find. So what's the problem with this? Well, the problem is we're only given the sine value. That's good news. We're going to put negative 4/5 right here. The bad news is we don't know what to put for the cosine value. So right now that's a question mark. Now we can figure that out. You just have to think back to our work with triangles. And so there's a couple things that we need to pay attention to. First of all, this information right here tells us which quadrant we're in. So this is quadrant 3. If we're between 0 and 3 pi over 2, it means we're in this area. And the reason that I'm pointing that out is we know that both sine and cosine are negative in that quadrant. So when I set up my triangle, I'm going to draw the standard triangle, but I'm going to pay attention to those signs. If I pop theta down here, when this says the sine of theta equals negative 4/5, what they're telling us is that the opposite side is negative 4 and the hypotenuse is 5. And our job is to find the adjacent side so we can do the cosine, right? Cosine, this guy right here, is adjacent over hypotenuse. Okay, so I need to find this side of the triangle. To do that, we'll do the Pythagorean theorem. That would be the question mark squared plus the negative 4 squared equals the 5 squared. And so all we have to do is compute 25 minus 16 and then take the square root. Well, the square root of 9 is 3. But remember, because we're in the third quadrant, we actually need the negative of that square root, so our value is negative 3. And then that means the cosine would be negative 3 over 5. So instead of this question mark here, I'm going to erase that, and I'm going to put that negative 3 over 5 in right here. So if we're asked to find the sine of 2 theta in this situation, the calculation that we'll do is 2 times negative 4 over 5 times negative 3 over 5. And that value will be 1224 over 25. And that's positive because a negative times a negative is a positive here. And that turns out to be the correct answer for this problem. Again, let me remind you what we did. I went right to the find statement to decide which formula to use. That's how we knew to use the sine double angle formula. I needed to get a cosine of theta because we were only given a sine of theta. To do that, I needed to pay attention to the quadrant that we're in this case between pi and 3 pi over 2, and use the Pythagorean theorem to solve for the missing side so I could do adjacent over hypotenuse. Once you have that second value, you're good to go on filling in the numbers, multiplying them out based on this formula, right? We're using this identity right here, 2 times sine theta times cosine theta, to get the value. And that's our goal. When it says find sine of 2 theta, it wants the fraction form of that value, that sine value, the sine ratio, if you will. Okay, that was a tough one because we had to pay attention to this third quadrant and we had to find the extra cosine value. Let me show you another example. In this problem, we're given the cosine of theta equals negative 5 over 13. And the quadrant that we're associated with is 5 pi over 2 to 3 pi. So you have to actually visualize this thing. I'm going to draw this over here on the side. Remember, if I go around once, that's 2 pi, or 4 pi over 2. 5 pi over 2 starts right here. Oh, I need a new color. 5 pi over 2 starts here, and then 3 pi would be over here. So we are working in quadrant 2. That's the important piece here. That's what this information is telling us. In quadrant 2, cosine is negative, but sine is positive. That's the important thing to pay attention to here. Now we are asked to find the cosine of 2 theta, and the only thing I know is that the cosine of theta equals negative 5 over 13. So, good news is we have a formula that only requires us to know the cosine of theta in order to get this problem. So I'm going to use this formula here, the second of the cosine 2 theta formulas. I'm going to use cosine 2 theta equals 2 times cosine squared of theta minus 1. And since I already know what cosine of theta is, I can just square that and find this value. So it's going to be 2 times negative 5 over 13 squared minus 1. And so I multiply this out, and I get 2 times 25 over 13 squared, which is 169, minus 1. That's going to be 50 over 169 minus 1. When you do that subtraction, that is negative, oh goodness, 119 over 169. And that is the cosine value for 2 theta, this guy right here. Negative 119 over 169. Because we used this formula here that did not involve a sine function, we didn't even need to use the fact that we were in the second quadrant because we didn't worry about the sign being positive there. All we had to do was put our cosine value in here and square it, and then use the formula. So in this video, I showed 2 examples of some more complicated types of double angle problems that we are working on, where I give you a particular trig value and ask you to find the value for the double angle. Give these problems a try, and of course, if you need any help, just let me know. In the meantime, take care.